Hello everyone, I am Dr. Naresh Kumar, Assistant Professor in the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are going to have a discussion on superposition theorem and its related problems. So first I will state a superposition theorem statement. Total response equals to sum of the individual responses in a linear bilateral network. Here response is either voltage source, either voltage or current. Now here if you see the statement, it can in a linear bilateral network. In a linear bilateral network, the network should be linear bilateral network having greater number of sources. Means the network should be multiple, so should consist of multiple number of source. The network may be multi-source network. So having greater number of sources, and the response here, the response may be either voltage or current, not for power. So the response means total response equals to total response in any element, in any resistor, any inductor or any capacitor, in any element equals to summation of all responses. Summation of all responses caused by individual sources acting alone. That means summation of individual responses. That means all responses caused by individual sources acting alone. In that case, remaining all other sources are deactivated. That means voltage sources are replaced by short circuited and current sources are replaced by open circuited. While other sources are eliminated from the source means, from the circuit means here all current sources and voltage sources are deactivated. Now, if you see this circuit here, how many sources here? Two voltage source V1, V2 and one current source I1. Means we can apply superposition theorem. There are two limitations here. So, we cannot apply superposition theorem for single source network because here because if we have only single source network, so we will not get individual source responses. Means here we have three number of sources, V1, I1 and V2. Now calculate the response in any element, either voltage or current. Suppose I am taking here R4 response current, IR4 response current I am calculating here. Now here this is the current, or you can use VR for voltage also. Either response may be either voltage or current in any element. Here element I am taking as a resistor and the response I am taking as a current. Now here the multiple, this network having multiple number of sources means here we have three sources, then we can apply super, and this is a linear bilateral network. All elements are linear and bilateral means. Now here if you see the first line here, in a linear bilateral network, this network is a linear bilateral network having a greater number of sources. It is a multi-source network, multiple three number of sources, two voltage sources and one current source, and the response is current. So I am considering here that the response is current, and in a element here I am considering the element as a resistor, and summation of individual responses means individual sources acting alone. At that case, calculate the responses. That individual responses summation should be equals to total response. So that I will if you see this diagram here. So now in the first case, total response means V1, I1 and V2 are active, and calculate the IARE. Now in the individual responses, individual source acting alone means here only one voltage source is active and remaining all other sources are deactive. Here deactive means while other sources are eliminated from the circuit. While other sources are eliminated from the circuit means current sources are replaced by open circuit and voltage sources are replaced by short circuit. Now here how many elements total? Three voltage sources. How many how many sources here? Three number of sources. Now here we have three number of sources, means one voltage source, two voltage source, and one current source. Here current source V1 is active, and I1 and V2 are deactive. Deactive means current source I1 is deactive, means that current must be 0, that current source value must be 0, and this V2 value must be 0. When it will be that current source value is 0, when it is a open circuit. Open circuit current is always 0. Now when voltage source value is 0, now short circuit voltage is 0. Now here voltage source is replaced by short circuit, and this current source is replaced by open circuit, and this V1 is active alone. Now calculate this IR4 dash, and same way here current source is active, I1 is active, and V1 and V2 are deactive. These two are deactive means, so this voltage must be 0, and this voltage must be 0, and this is replaced by short circuit, and this is replaced by short circuit. Now here calculate this IR4 double dash. This is individual response 1 IR4 dash, and this is individual response IR4 double dash, and in the fourth case V2 is active, and I1 is deactive. That means replaced by short circuit, that current must be, so not short circuit, open circuit current is 0, and that value is 0. This is open circuited, and this V1 must be deactive, that value is 0, V value, that is when it will be 0, it is a short circuit condition, that voltage source value is 0. Now it should be replaced. Now current source is replaced by open circuit, and voltage source is replaced by short circuit. At that case calculate the IR4 triple dash. Now we have three individual responses, that means three currents, individual currents and total current. Now here according to the superposition theorem, IR4, this current equals to this current plus IR4, this IR4 dash plus IR4 double dash plus IR4 triple dash. This is the statement. In a linear bilateral network having more number of sources, multi-source, in a multi-source network, linear bilateral network having greater number of sources, total response equals to that current. That response may be either current or voltage. Here in this case I am considering current as a response, and total response equals to total response in any element. Here that element is R4, and that response equals to sum of the individual responses. Here individual response 1 calculated when V1, when one voltage source is active and remaining V1 voltage source is active, and this I1 and V2 sources are deactivated. At that case I calculate individual responses 1, and individual response 2 is calculated when I1 is active and V1 V2 are deactivated. At that case I calculated IR4 double dash, and V2 is active. Individual response 3 IR4 triple dash is calculated when V2 is active and current source I1 is replaced by open circuit and V1 is replaced by short circuit. That in that case I calculate the individual response 3. Now IR4 equals to IR4 dash plus IR4 double dash plus IR4 triple dash. Total response equals to sum of the individual responses. Now we have two limitations. It can be applicable only for multi-source network, and the response may be either voltage or current, not for power calculations. Here the response should not be power, because V is directly proportional to the, sorry. So here V1 equals to I1 plus I1 into R1, I equals to I dash plus I double dash, and V dash equals to V dash plus V double dash. Now that equals to V into I into R plus I into I dash into R dash, and I double dash into R dash. But in case of power, I square R plus I square R, I square double dash, I square double dash, I power equals to. Now here power should not be I square R. So this is I square. It is not linear. It is I square is a not linear case. So I is a linear case, V is a linear case, and power is not linear. So now we cannot apply power calculations superposition theorem. Now if you take, now let us take, now in the second statement, in a linear bilateral network having multiple independent sources, the response of any element will be equals to algebraic sum of responses of that element considering one source at a time. This is second statement. Now let us take one problem. First I will give you the steps. What are the steps involved in the superposition theorem? So steps to follow the superposition theorem. For superposition theorem, so first step 1, first identify the number of individual independent voltage sources available in the network. So now here, how many number of voltage sources? Here V1, I1 and V2 sources are available. Total 3 number of sources are available. Now second step, choose any one source and select one source as a select one source, and remaining all sources are discussed in the previous slide. I explained. So select one source. So one source should be active and remaining all sources must be deactivated. If it is a current source, that is replaced by open circuit. If it is a voltage source, that is replaced by a short circuit. If any network consists of any dependent source, that is kept as it is. So you cannot eliminate it. So it should be as it is. Don't consider it as a active source. Remaining all independent sources are deactive. Now it remains as it is throughout the calculation. It should be as it is. Now third step, step 3. Now in a circuit only one independent source is present. So while calculating the response, individual responses, one source is active and you need to find the responses with only one energy source is active. And repeat the step 2 and step 3 for all energy sources for V1 and V2 and V3. At a time only one source must be active. If all 3 sources are independent sources, you need to repeat these steps 3 times. So here we have 3 sources, means 3 individual responses we will get, and every time you get same values of the response. Now the combine all the responses by algebraic sum of summation obtained by individual sources. Now let us take one problem. Find out the current flowing through the 47 ohms resistor by using superposition theorem. Here this problem, here how many sources? Here step 1, one source, one voltage source, and second one is also voltage source, 15 volts and 10 volts. Now here 15 volts and 10 volts active, and they calculate the current flowing through the 47, I47 dash. I47 is the total response. Now here individual responses are calculated. 15 volts is active and 10 volts are deactive. So 10 volts are deactive means 0 volts. 0 volts means short circuited. it should be short circuited. And second individual response, now calculate the I-47 dash, and this is I-47 double dash. I-47 double dash means, so here 10 volts active and 15 volts deactive. 15 volts deactive means that is replaced by short circuit. This is 10 volts and this one is 10 volts. Now here I-47 equals to I-47 dash plus I-47 double dash. It should be verified. Now if you apply KVL, so it should be verified. So I-40 total response equals to sum of the individual responses. Now, so if you calculate, how you will calculate this I-47 dash? By applying mesh analysis. 15 minus 82 I1 minus 47 I1 minus I2 equals to 0. This is I1 and this is I2. And this is 129 I1 minus 1. This is 129. 82 plus 47 is 129 and this is minus 47 I2 equals to 15 I1. So now this is equation number 1. If you apply KVL in this loop, 47 I1 minus I2 minus I1 and 100 I2 equals to 0. And if you simplify this, minus 47 I1 plus 147 I2 equals to 0. That is equation number 2. If you solve these two equations, you will get 0.131 and 0.042. These are the mesh currents, and we need this I-47 dash. Here I-47 dash means I1 minus I2. So I-47 dash equals to I1 minus I2, that equals to 0.131 minus 0.042. That equals individual response 1 is a 0.089. Now here for the second case, second circuit, I1, this is I2, same thing, but here this 15 volts is replaced by short circuited. This value is 0 and there is a 0 value. Minus 82 I1 minus 47 I1 minus I2 equals to 0. If you simplify this one, same thing, 129 I1 minus 47 I2 equals to 0. Now here minus 47 I2 minus I1, this one second one, and minus 100 I2 minus I2, this is minus 10. Now this, if you simplify this one, minus 47 I1 and plus 147 I2 equals to 10 minus 10. This is equation number 1 and equation number 2. If you solve these two equations, you will get this I1 and I2. And I1 equals to 0.028 and I2 equals to minus 0.076. So now we have, these are the mesh currents. From this mesh currents, calculate this response current. I-47 dash equals to I1 minus I2, that equals to minus 0.028 minus of minus 0.076, that equals to 0.048. Now here we have two values. This is 0.089 plus this is 0.048. Now that equals 0.0137 amperes. This total current equals to. Now here calculate the find out current flowing through the 47 ohms resistor by using superposition theorem I-47. So now here, so we can use mesh analysis, but using superposition theorem. First calculate the individual responses and add that summation, algebraic summation must be equals to total response. How you will verify this? So by applying mesh analysis, this value is 0.137. So same thing, so I1, I2, so two meshes, 1, 2, so 15 minus 82 I1 minus 47 I1 minus I2, that equals to 120 I1 minus 47 I2 equals to 15, and minus 47 I2 minus I1, 100 I2 plus minus 10 equals to 0. Second, so this is equation number 1 and this is equation number 2 is minus 47 I1 and 100 plus 47 is 100 I2 minus 10 equals to minus 10. So if you solve that, 0.0103 and 0.034, that is minus. So now here I-47, this I-47 equals to I1 minus I2, that equals to 0.0 103 and minus 0.034, that is 137. Now superposition theorem is verified. Now second problem, current flowing through the 8 ohms resistor using superposition theorem. Now here, so 28 volts and 28 amps, one voltage source and one current source, then we can apply superposition theorem. Here the response is a current, that means 8 ohms resistor element. So here I 8 ohms resistor you need to calculate. By mesh analysis we can calculate the 8 ohms resistor, but here using superposition theorem calculate the current flowing through the 8 ohms resistor. Now here 28 amps are active, voltage current source is active, and 28 volts voltage source is deactive. That means that value, that is 0, that is replaced by short circuit, this one and this one. And second case, 28 volts are active and 28 amps are deactive, current source is deactive. So this one is 0, this means it is replaced by open circuit. Now here this is I8 double dash, this is I8 dash. I dash plus I double dash equals to I8. According to the superposition theorem, total response equals sum of the individual response. 8 ohms resistor, this is total response, and individual response 1 and is individual response. First find out the individual response 1. Here the 0, this 28 volts is replaced by short circuited, means this value is 0, and this 6 into I1, this is dropping voltage, resistive drop, minus 6 I1, and this is 8 ohms resistor drop. This current is I1 minus I2, this is I1 and this is I2. Minus 8 I1 minus 8 I2 equals to 0, and if you simplify this one, so 14, so 6 plus 8, that I1, and minus 8 I2 equals 0. This is equation number 1. Now here I2, this I2 current equals to, this I2 current equals to, I2 current directly we can consider as a this current source value. This current and this current is same. I2 current is 0. So if you know the I2 current, then we can calculate the I1 value. So now here I1 value equals to 16 amp. Now here we need 8 ohms resistor current. 8 ohms resistor current means I1 minus I2. Here this 8 ohms resistor individual response 1 current is I1 minus I2 equals to 16 minus, this is I1 is 16 and I2 is 28, that equals to 10. Now second individual response is calculated. 28 volts is active and this current source is deactive, means I2 value is 0. This is I1 and this is I2. I2 equals to 0 because this is open circuit current value is 0. Minus 28 is the rising voltage EMF 28 and 6 into I1, that is minus, and 8 into I1 minus I2, this is also minus, that is resistive drop. Now here 28 minus 6 I1 minus 8 this is 8 I2 equals to 0, equation number 1. Now here 28 minus 14 I1 equals to 0 because this I2 value is 0. This I2 because of open circuit current is 0. Now I1 equals to 2 amperes. So now here we need I8 double dash current. That I8 double dash current equals to this is 2 and this I2 value is 0. That is 2 amperes. Now here this is minus 12 and this is plus 2. That equals to minus 10 amperes are the current flowing through the 8 amps. Minus 10 amperes this current equals to, according to the using superposition theorem. Now verification means when two sources are active, apply mesh analysis. You will get the same value 10 minus 10 amperes. So at that case, so 28 same answer, same 6 into I1, this is I1 and this is I2 equals to 28 and 8 into I1 minus I2, so 14 I1 minus 8 I2 equals to 28, that is equation number 1, and second equation is I2. This is equation number 2. Substitute this I2 in this, you will get I1. So now here this one, so 18 amperes. This is I1 is 18 amperes. Now the current flow into the 8 ohms resistor equals to 18 is the I1 and 28 is the minus 1. So this is minus 12 plus 2 equals to 10 amperes. So using mesh analysis also we got same value, that is 10 amperes. So this is not total response current. I8 equals to this. I8 equals to minus 10 according to the mesh analysis superposition theorem. So we got same value. Now third question, current flow into the 1 ohm resistor using superposition theorem. Now here 0.02, 0.02, 0.02 and 1 ohm and 130 and 130. Now it is a linear bilateral network and we have two number of sources, then we can apply superposition theorem, and here the response is the current, then we can apply it is not power calculation, then we can apply superposition theorem at 1 ohms resistor, in a 1 ohms resistor. Here where is the 1 ohm resistor? This is now here. So now individual response, how you will draw the individual response circuit. One and individual response circuit is 130 volts is active and 110 volts is deactive. That means this is 0 and this is replaced by short circuit. So 130 volts is active and this is replaced by short circuit, that is that value is 0. Now here second case, 110 volts is active and 130 volts is deactive. 130 volts is deactive. Now calculate the individual response. This is calculate the individual response 1. This is I1 ohms dash and I1 ohm double dash. This is I1 ohm. So now the verification is I1 ohm equals to I1 ohm equals to I1 ohms dash plus I1 ohms double dash. Total response equals to sum of the individual responses. Now individual response calculations. First individual response 1, 130. This is I1 and this is I2. 130 minus 0.2 I1. 0.2 I1 minus I2 equals to 0. Now 0.2 plus 0.2, that is I1, 0.4 I1, and this is 0.2 I2, that is minus I2 equals to 130. Now minus 0.2 I2 minus I1, 0.2 I2, that is minus, and minus 1.2. Now 0.2 I1 minus, that is plus 1.4 I2. I1 equals to 350 and I2 equals to 150. And here the individual response current is I1 equals to this I1 ohms. I1 ohms resistor is different. This I1 is different. I1 is a mesh current and this I1 ohm is a branch current. That is individual response current. That current equals to I2 dash. This current, this I2 equals to this current is this one. So I1 dash equals to I2. This I1 dash equals to I2. That equals to 50 amperes. Now second case 0, this is replaced by short circuited. So 130 volts is replaced by short circuited 0 volts and this is replaced by short circuited. This is 0, same thing, same equation here. 0.2 I1 minus 0.2 I1 minus I2 minus 110 equals to 0, and same 0.4 I1 minus 0.2 I2 equals to minus 110. So here 110 volts is active. So this is, so in the previous case there is no 110 volts, so that value is 0. And now second case, so minus 0.2 I2 minus, same equation, but here one extra value is voltage source, minus 0.2 I2 minus I1, that is minus 0.2 I2 and minus 1 ohm plus 110 volts equals to 0, and minus 0.2 I1 plus 1.4 I2 is equal to 110. If you solve these two equations, you will get I1 and I2. I1 equals to minus 253 and I2 equals to 42.3. Here this I1, this individual response 1 equals to 50, and this individual response I2 equals to this one equals to, this is I1 and this is I2. This I2 equals to 42.3. So 50 plus 42.3 equals to 92.3 ohms resistor. This current equals to 92.3 ohms resistor by using superposition theorem. But the verification part according to the from the mesh analysis. So this is 42 ohms, and from the mesh analysis now here. So from the mesh analysis now consider 130 volts and 110 volts active and calculate this I1 ohms dash. So same equations, 130 and 110 volts active here. Now here same thing, 130 minus 0.2 I1 minus 0.2 I1 minus I2 minus 110 equals to 0, that equals to 0.4 I1 minus 0.2 I2 equals to 20 minus 0.2 I2 minus I1, this is I1 I2, and I2 equal I2 minus I1 minus 0.2 I2 minus 0.2, sorry, 1 I2 plus 110 equals to 0. Same equations, but here 2 volts are active, minus 0.2 I1 plus 1.4 I2 equals to 110. Solve these two equations. So this is 96.1 and this is 92.3. Now here current flow into the 1 ohms resistor equals to I1 ohm equals to I2, that equals to 92.8. This is 50 plus 42.3, that equals 92.3. So according to the superposition theorem is same as according to the mesh analysis. If you use nodal, if you use Thevenin's, if you use Norton's, you will get the same value, 92.3. Now here, now current flowing through the 10 ohms resistor by using superposition theorem. Now here we have 3 number of meshes here. First circuit, so 4 ohm, 4 volts and 10 volts. It is a multi-source network, then we can apply superposition theorem. It is a linear bilateral network, then we can apply superposition theorem. The response is the current, so then we can apply superposition theorem. Here the element is 10 ohms. So here 10 ohms resistor current I10. Now here individual responses, only 4 volts active and 6 volts deactive. And that is deactive means voltage value is 0, and this 0 volts are replaced by short circuit, and this short circuit, it is replaced by short circuit, this is replaced, and this one, and calculate the individual response 10 I10, that is I10 dash, and second individual response is calculated I10 double dash. So this is 10 volts, that means 4 volts is replaced by short circuit. So 6 volts active, this should be active, and this 4 volts is deactive, and deactive means this is 0 volt, this 0 volt, and this is replaced by short circuit. This is replaced by short circuit. Now here I47, I10 equals to I10 dash plus this one equals to this one. I10 equals to I10 dash plus I10 double dash. Now, first calculate the individual response 1 I10 dash, and then calculate the individual response I10 double dash from the mesh analysis. And when two sources are active, that means calculate the 10 ohms resistor current, that means total response current. So now then verify. Now here 4 volts active, this is 0 volts, so calculate the individual response 1 I10 dash. Now here this one I10 double dash, this is 0 volts, 6 volts active, here 4 volts active. At a time only one source is active, one independent source should be active, remaining all other sources are replaced by their internal resistances. Now here I10 equals to I10 dash plus I10 double dash. Now here 4 minus 5 I1. So this is I1, this is I2, and this is I3. So here 4 is the rising voltage and 5 minus I1 and minus 15 I1 minus I2. And second, if you simplify this one, what will be the equation? 19 I1 minus 15 I2 plus 0 I3 is equal to 0. So 5 plus 15, that is 19, minus 15, and there is no impact on third element current, third mesh current I3. So that value is 0 and is equal to 4. Second mesh equation, 15 I2 minus I1 and 10 I2. Next, 8 I2 minus I3. So you can take all are minus or all are plus. Now, simplified equation, what will be the equation? Minus 15 I1 and minus 8 I3 and 15 plus 10, 25 plus 8, that is 33. Now, equation number 2, that is equation number 1 and equation number 2. What would be the third mesh equation? So, minus 8 I2 minus I3, I3 minus I2 and 12 I3. This is also minus. Now, the simplified equation, 0 I1, there is no impact on I1 for mesh 3. Now, minus 8 I2, minus 8 I2 and 12 plus 8, 20 I3 equals to 0. Equation number 1, 2 and 3. That equation I1 equals to 0.0449 and I2 equals to 0.175 and I3 equals to 0.073. Now here I10 dash we need only here from the mesh analysis. So here I10 dash means I2 current. So what is the I2 current? I2 current is the I10 dash individual response current. Here we need I10 dash to verify that, to find out the current flowing through the 10 ohms resistor. We need individual response 1 and individual response 2. So individual response current is calculated 175 and second I10 double dash is calculated, same thing, 6 volts active and 10 volts deactive. So in that case minus 5, there is no, minus 5, this 0, this is replaced by 0 volts, no 0, and minus 5 I1 this one and 15 I1 minus I2, that means that is minus. Summation of all voltages must be 0 according to the KVL. Now 19, same equation but this voltage, this value is 0, same thing, 19 I1 minus 15 I2 plus 0 I3 equals to 0, that is equation number 1. And second equation is same as it is here. So 15 I2 minus I1 and 10 I2, then 8 I2 minus I3. Now here minus 15 I1 minus 8 I3, 15 plus 10 plus 8, that is 33 I2. Next third mesh equation, 8 I3 minus I1, I2 and I3 minus I2, that is minus 12 I3, this is also minus, and this is plus to minus, that means minus. Now what would be the equation of third equation? 0 I1 minus 8 I2, this one, and this 20 I3 equals to minus 6. Equation number 1, 2, 3, and if you solve that by using Cramer's method, I1, I2 and I3. I1 equals to minus 0.105 and I2 equals to minus 0.133 and I3 equals to minus 0.353. Now here I2 current is the individual response current, that equals to plus minus of 0.133. So now here the verification part. Now if you add this, so now 1.7, so 0.17 and 0.17, this is minus, this is 2 and this is 4 and this is 0 and this value is 0. 0.042 is the total current flowing through the 10 ohms resistor using superposition theorem when two sources are active. So this current should be 0.042. Now the verification part, same thing. So 4 volts active, so this should be same, minus 5 I1, 15 I1 minus I2 equals to 0. Next, if you simplify this one, 19I1 minus 15I2 plus 0 I3 is equal to 4, that is I1. 15 I2 minus I1, second equation, and 10 I2 and 8 I2 minus I3 equals 0, minus 15 I1 plus 33 I2 minus 8 I3, that is equation number 2 equals to 0, and minus, if you apply KVL in the third mesh, minus 8 I3 minus I2, this one, and this resistive drop 15, this is minus, and this is plus to minus 6. So 0 I1 minus 8 I2 plus 20 I3 equals to minus 6. Equation number 1, 2, 3. If you solve that, you will get 0.243 and 0.0422 and 0.28. So this is minus. This current is a total current I 10. So now 0.0422 and this one is 1.77, sorry, 0.17, and plus this value is, so minus of 0. This is this one, and 0.13135, I think. Now this value equals 0.042. So almost same, 0.042 or 44. So almost same, this value and this value. Now find out the current flowing through 2 ohms resistor by using superposition theorem. Here 3 number of sources, 40 volts, 20 volts and 10 volts. This is plus, minus, plus, minus, plus, minus, plus. Now here we have 3 number of sources. We can apply superposition theorem. The response is current. Then we can apply, it is not a power, and the 2 ohms resistor current. This is I2 ohms resistor current. We are calculating using superposition theorem. Now individual responses, when 40 volts is active and remaining all other sources are deactive. 40 volts active, 20 volts and 10 ohms. 20 volts and 10 volts are deactive. 0 volt and 0 volt. 0 volt and 0 volt, this should be active, and these two are replaced by short circuited. These two are replaced by short circuited. Now second case, this calculate this I2 ohms dash, and here I2 ohms double dash is calculated. This 40 volts and 40 volts and 10 volts are deactive. That value is 0, deactive. That value is 0, and this is replaced by short circuited, and only 20 volts active. And calculate the I2 ohms double dash. And here 40 volts and 20 volts are deactive, short circuited. That value volts, this value is 0, and only 10 volts is active. And calculate the individual response T, I triple dash, I2 triple dash. Now the total response equals to sum of the individual responses. Now I2 dash is this one, and I2 double dash is this one, and I2 triple dash is this one. So first calculate the individual response one. I2 dash equals to, this is I1, this is I2, and here also I1, I2, 2 number of meshes, mesh 1, 2, mesh currents in clockwise direction, 1, I1, and this is I2. Now here I2 currents are all individual response currents for each circuit. Now 40 is a 40 minus 5 I1 minus 10 I1 minus I2. This, there is no 20 volt source, that value is 0, and the simplified equation 15 I1 minus 10 I2 equals to 40. 10 plus 5 is a 15 is equal to 40. Now minus 10 I2 minus I1 plus minus 2 I2 equals to 0. this value is 0. Now the simplified equation minus 10I1 and plus 12I2 is equal to 0. Now solve these two equations. I1 equals to 6 and I2 equals to 5. This I2 dash equals to 5 amperes. This current is this one. This I2 current and I2 dash current is same. And same way here, 20, this is 0 and 20 volts is active. So this in place of 20 volts active. So minus 15, minus 5 I1, minus 10 I1 minus I2, minus 20 equals to 0. 15 I1 minus 10 I2 equals to 20. Minus 10, second equation, minus 10 I2 minus same equation here, minus 2 I2. This equals to minus 10 I1 plus 12 I2 equals to 0. Solve these two equations, you will get equation number 1 and equation 2. Equation number 1 and equation number 2. Equation individual response current is the minus 2.5. Now, individual response current. So, these two are replaced by short circuited. So, this 40 and this 20, there is no impact on this mesh 1 of these two voltage sources, 40 volts and 10 volts. Only 5 into I1 and 10 into I1 minus I2 minus equals to 0. And next 10 plus 5 is 51 and minus 10 I2 equals to 0. And 10 I2 minus I1 and 2 I2 minus and there is only one source is active. 10 volts is active, that is 10 value. 10 volts equals to 0. Now minus 10 I1 plus 12 I2 equals to 0. 10. Equation number 1 and equation number 2. If you solve that one, so this one is 1.250 and this one is 1.875. Now here this value equals to 2.5 plus 1.875, that equals to 4.375. So this is the total response current according to the superposition theorem. Total response equals to sum of the individual responses. Now here these three currents we need to add here. Now if you apply KVL I1, I2 in the mesh 1 and mesh 2 using mesh analysis here, 40 minus I1 minus 10 I1 minus I2 plus 20. All sources must be active. So 15 I1 minus 10 I2 equals to 20. 40 minus 20 is 20. So here minus 40 and plus 20. Plus 40 and minus 20. And minus 10 I2 minus I1 minus 2 I2 and plus 10. So three sources are active here. Now the simplified equation minus 10 I1 plus 12 I2 equals to 10, equation number 1 and equation number 2. The solution is 4.25 and 4.375. So 5 plus this one and minus 2.5 plus 1.875. This equals to this one, 4.375. Now the theorem is verified. Total response equals to sum of the individual response. Thank you very much to you.
Like, share and subscribe. Hit the bell icon for more updates.